So this is the extensive practice that I asked you to do. I gave you question number 2 here. So you need to identify from the description given whether it is a histogram, frequency polygon, or ogive. So first one, they represent the cumulative frequency in a frequency distribution. So it's an ogive. And then this one, you can see side by bars, for sure it's histogram. And the last one, it connect the midpoints, okay, of the class interval. So this is a frequency polygon. For question number 3, so from the box plot, you can identify there the histogram to represent the first one here is the third box plot. And then for B, the answer is this one. For C, the answer is A. You can see it's skewed right. So skewed right. And then for the last one, this is a symmetry. So B is the one. Okay, now we continue with question number 8. Number 8, Okay. You're given the frequency table that shows the blood pressure reading taken from a group of patients before and after taking the dose of type of medicine in lowering blood pressure. So you can see the systolic blood pressure in millimeters of mercury here, before and after with the reading over here. So they ask you to calculate the mean and standard deviation of the data. And then they ask you, is the medicine effective in lowering down the blood pressure of the group of patients after taking a dose of the medicine, and justify your answer. So we need to see after they take the medicine, is there any improvement or not? So before taking the medicine, we found the mean, it is 151.6. You check your answer. And then after taking the medicine, the mean is 142. I'm sure you know how to find the mean, right? The mean is the midpoint. Okay, midpoint multiplied by the frequency, and then you add up all of it like this, divide by the total frequency. So after that, to find the standard deviation, that's the total of fx squared. So 127 squared times 4 plus 142 squared times 7, and so on, you will get the total fx squared. 580,360 over 25 minus 151.6 squared, that's the mean. So we will have the standard deviation of 15.23 before taking the medicine. After taking the medicine, the standard deviation is 508,600 over 25 minus 142 squared. So the answer is 13.42. Okay, so after that we compare. Last time I've told you that the mean, the higher the better, right? But in this case, because we need to find before and after for the systolic blood pressure. If you have a very high blood pressure, is that good?
No.
Most probably you might have a stroke or anything. So actually, for the mean over here, we need to determine the lower mean. The lower, the better, actually. So if you compare 151.6 and 142, after taking the medicine is better. Whereas for standard deviation, this one 15.3 before, after is 13.42. So of course, the standard deviation, the lower the better. Meaning after taking the medicine is better. So when you answer the question, yes, because the mean after taking the medicine drops from 151.6 millimeters of mercury to 142, and the standard deviation is smaller. Okay, so now if I ask you a question, just now regarding the mean, last time is about the better, the bigger the better, right? So if I change the question over here, my total savings every month, if I find the mean for my savings every month, is it the bigger the better or the smaller the better?
Bigger better.
Yes, saving. Of course, the bigger means I have more saving. Now I change the question. What about loan repayment? Mean for loan repayment every month, is it bigger the better or smaller the better?
Smaller.
Yes, smaller the better, because that's the remaining amount of your loan. The smaller the better, meaning that you have less debt to the lender. Okay, so make sure you know how to find the mean, how to explain for the mean. Now we look at question number 9 here. The ogive on the right shows the distances of shot put obtained by Rosidi and Wildan. So you can see the red graph over here is Rosidi and the blue one is Wildan. In a training session, they ask you to calculate the percentage of the throwing that exceeds 15.45 meter obtained by Rosidi and Wilton. So what we need to do is you need to find out 15.45. 15.45 is in the middle here. The one in red that I plotted using the red dash line here. So you move up, you can get the reading of 11. That is for Wilden. And then the reading for Rosidi is 15. So from here, to find the percentage, actually you need to minus 20, you minus 15. This one is for Rosidi. So 20 minus 15 over 20, you multiply by 100% because you want to find percentage. So the answer is 25. And then for Wilden, 20 minus 11, so you get 45%. For median, you see question B here, based on the median and the third quartile of both performances, determine who performed better during the training session. So we need to look for the mean and median. Median and the third quartile. This is the median. 20 divided by 2, so it's 10. You look for the value. So the value, the first one is 14.45 and the other one is 15.25. I've written down here. And for the third quartile, this is the third quartile. So you can see the reading. This is the one, the original one, which is 15.45 and 16.45. So I stated down the value over here. Okay, then they ask you, determine who performed better during the training session. Who performed better? Can you see? Shot put. Shot put means the longer, the better you throw, right?
Yes.
So if you look at the median, Rosidi and Wilden, who can throw better?
Wilden.
Okay, same with the third quartile. The value of Wilden's third quartile is more than Rosidi. So Wilden have performed better during the training session. That is how you answer. Okay, do you have any question for this one?
No.
No, So we carry on with the next topic. That is the last topic in your syllabus. Mathematical modeling is a new topic for you all. So I'm going to let you see the tree first. Okay, so in this mathematical modeling, we only have one subtopic, the only one. And today we are going to learn the first one here, explain mathematical modeling. You need to know how to explain it. What is a mathematical modeling later on. And in the next lesson, we are going to see this one, solve the real life problem through mathematical modeling that involve linear, quadratic, and exponential function. Okay, so let's go on first. Sorry, I need to talk very fast. We have less time. Okay, so if you look at this picture here, this is a picture of a smart tunnel. You ever went to West Malaysia, right?
Yeah.
They have this smart tunnel. There is a purpose for the smart tunnel over here. Okay, the SMART stands for Storm Water Management and Road Tunnel. It aims to drain flood water during heavy rain in Kuala Lumpur. However, the tunnel also has an additional function in reducing traffic congestion. The unique design and innovative way of operating the tunnel presented challenges to the engineer at the beginning of its construction. Now the question here, do you know that mathematical modeling was used to demonstrate the 4 different operations mode of the smart tunnel? So this chapter, the topic that we learn over here, they use it to demonstrate the 4 different operation mode. What are the 4 operations mode of the smart tunnel? Do you have any idea? The operation mode is like this. Okay, you can see the picture on the right over here. So mode 1, when there's no storm, the traffic can flow very well. Okay, so all the motor can just go along the tunnel. And then when it comes to the second mode over here, second mode is moderate storm. Okay, this system, the smart system, will be activated now when it comes to the second mode over here, whereby the flood water is diverted into the bypass here, down here, okay, into the bypass, so that the water level is lower, but then the motor still can run. Okay, after that, the third mode is the major storm. So now you can see there's no motor anymore because it's getting more dangerous Okay, and then the last mode is a prolonged major storm. The water level is very high already, so it will be closed. Okay, this one you can see from the internet lah. You can search yourself. Now we enter into the important part here. This is the definition of a mathematical model. Right now, you might not understand the definition. I just let you know briefly first. A mathematical model is a representation of a system or scenario, okay, that is used to gain qualitative and or quantitative understanding of some real world problems and to predict future behavior. So later on, we are going to learn to apply this on one of the question whereby you are given a real world problem and then you are going to represent the system or scenario, and then we are going to gain the qualitative or quantitative understanding of the problem, and we are going to predict what will happen. So it looks very complicated, but slowly, you try to digest the meaning over here slowly. Okay, now I have to proceed. So consider the problem. Okay, the population of town A is 40,000. It is known that 45% of the residents in the town practice the habit of recycling using plastic drinking bottles. Okay, so 45% out of 40,000. If each person in the town uses 5 plastic drinking bottles per week, how many bottles are recycled each week in the town? So over here, can you get the answer? Can get the answer or not?
Yes.
We can get the answer, right? We just need time to do the calculation or the computation over here. So actually, this kind of problem, it can use to help us find out or understand a particular mathematical concept. And then use the skill that we have learned, we try to find out how many bottles are recycled each week in the town. So we are not going to use, not going to use this kind of question to apply in the mathematical modeling because this is like a close-ended question. We can find out the answer straight away. Okay, now we look at the second question here. How long does it take? How long does it take to clean up an oil spill in the ocean? How long is an open-ended question. Do you have enough information over here to find out how long?
No.
Cannot, right? We don't have enough information like just now. They give you the 40,000 and then 45% and then 5 bottles per week. It's very detailed. But this one, they just ask you how long without giving all the information. One day, how many oil spill can be cleaned up, and then how many people is doing the job, what are the machines that is used, and so on, what kinds of method that is used, we don't know. So over here, we consider this is the real world problems, the one that is happening in the real world. And then we need to use both the mathematical knowledge and creativity to solve it. So in this part over here, for this kind of question, we have to apply using mathematical modeling. Okay, because mathematical modeling over here, it is suitable for open-ended question like this. Okay, now we are going to enter the mathematical modeling component. So this part over here, you have to memorize the important components in mathematical modeling. So I simplify, I make an abbreviation for you over here. I am a very robust robot. You know the meaning of robust, right? Okay, so how many steps you can see? 1, 2, 3, 4, 5, 6. 6 components over here. The first one, I stand for identifying and defining the problems. Okay, M, making assumptions and identifying the variables. Okay, for this second components over here, usually we are going to split it into 2. Making assumption, one part, identifying the variable, one part. We are going to see this later on. I'm going to show you why it is divided into 2 parts. A stands for applying mathematics to solve problems. V, verifying and interpreting solutions in the context of the problem. R, refining the mathematical model. and the R over here reporting the finding. After you finish up everything, you report what you have found out. Okay, so this part over here, you go and memorize yourself. I gave you the short form already. I am a very robust robot. Okay, we carry on from the real world problem given right now. Okay, what is the problem? The problem here refer to the grocery store, which is far from your house, sells a pack of 10 kg rice at a lower price. Okay, lower price meaning it is cheaper than the one closer to your house. So the one that is closer to your house is more expensive. Is it worth the drive for the cheaper deal? So you have to figure out whether it's worth or not. Okay, so over here, we will have to apply the mathematical model to solve the problem. So this is the one that we just learned. I am a very robust robot. Okay, so start from I, identifying and defining the problem. So you need to define and identify the problem over here. To buy a 10 kilogram of rice, which one are you going to buy? Are you going to buy from the shop that is further from your house or the one closer from your house? So this is the figure, the diagram that's showing your house. And then this is store A, the one that is closer to your house, but it's more expensive. Store B, further, but it is cheaper. Okay, so what we need to identify over here, we need to find out the pack of the rice. The price of a pack of 10 kg rice and the cost of petrol. Okay, cost of petrol. Second, you determine the distance because we don't know how much is the distance. For you to solve the problem, if you want to find out, if you want to compare, you will need the distance. After that, find the information needed from the internet. For example, the price of a pack of 10 kg rice from each store, the distance of each store from your house, the current petrol price because the petrol price changes every week, and the car's petrol consumption rate and so on. So for example, Hilux, if you compare a lorry or with the car which is smaller, the petrol consumption will be higher. So also you have to find out what kinds of car you are using if you really want to calculate everything there. So this is under identifying and defining the problem. You define it, you identify it. Okay. Second step, making assumption. So we need to make assumption over here right now. Assume what? We assume the route between the house, store A and store B is a perfect straight line like this. But this is impossible in the real life. For sure, if you want to go to the shop, they will be turning to the left, turning to the right, and then you have to slow down and so on. But because we need to do calculation, we cannot consider all those things so much, or else it will be very complicated later on. Therefore, we make an easier assumption over here, that is, it is a straight line. Okay. Next, driving cars to the store. You are driving the cars to the store. You are not walking to the store. You are not cycling to the store. Okay. And then the last one, purchasing the same number of brand of rice at store A and store B. Okay, this one usually we don't use one. We need to compare. You can put 2 and 3 and more so that we can compare. If you buy more, are you going to save more? Okay, purchasing the same number. For example, you buy 2 here, you are going to buy another 2 packs from store B. So the first 2 components, are you okay with it so far?
Yes.
Yes. So far, I'm giving you all of this explanation. In the next class later on, you will have to come out with your own identification and defining the problem and so on. So this is making assumption. Just now, you can see in the diagram, the flow chart over here, making assumption and identifying the variable, it is one component. But over here, they separate it into 2, making assumption and you need to identify the component right now. Okay, identifying the component, the variable, So this part over here, you have to think of yourself. Let you make assumption and identify the variable. This is the variable over here. The small letter s is the distance between store A and store B. P1 is the price of a pack of 10 kg rice at store A. P2, there is a price of the 10 kg rice at store B. The M is the petrol consumption rate of the car in kilometer per liter. So you need to calculate. For example, if that car can go 100 kilometer, how much is the petrol needed? So from there, you calculate the petrol consumption rate that is using M. N is the number of packs of 10 kilo rice to be purchased. Okay, so this one referring to the number of rice, the packs of rice you are going to buy. H is the current petrol price in RM per liter. S is the difference in price in RM for purchasing the pack of 10 kg rice at store B as compared to store A. So this one means you already deduct them. You found the difference. S. T is the difference of cost of petrol driving to store B compared to driving to store A. So that is the difference of cost of petrol. Okay, you can see there are so much variable over here. So we have to think one by one slowly. Okay, now the next one is applying mathematics to solve problem. So now we are going to apply all the variable that we have over here with a value so that we can solve it. Solve the problem over here means that we are going to get the answer for both situations, whereby you are going to buy, is it worth enough to buy from store B compared to store A, or better to buy from store A? Okay, so over here they make assumption, not make assumption because they already research in the internet. They found out the price of a pack of 10 kg rice for store A is 25 ringgit 95 cents. It's more expensive. You can see here. Compared to store B, is 23 ringgit 99 cents. Okay, so this one cheaper, but it is further. Now, let the quantity of 10 kilogram of rice to be purchased to be 2 packs. So the make assumption, the N over here is equal to 2 packs. You remember the variable that they make assumption just now? So 2 packs. And then the price to be packed, so it will be 2 multiplied by 25.95, you get the answer. And then store B, same thing, you get the answer. So therefore, by purchasing the rice at store B, one can save how much? You just need to find the difference, 3 ringgit 92 cents. Now, let the distance between store A and store B be 6. The petrol consumption rate of a car be approximately 17.6 km per liter. All of the number over here are actually assumption, but then you have to make a logic assumption, okay, such as the rice store A is more expensive than store B, so your assumption must be logic. Okay, let the current petrol price be 2 ringgit 8 cents per liter. Petrol needed for the 6 km route, okay, it will be the distance divided by the rate. The rate is 17.6. So meanings for 6 kilometer, it will need 0.341 liter. So cost of petrol for the 12 kilometer two-way route, you have to use this times 2 because one is through, go there, and then one is coming back. So 0.341, you multiply by 2.08 per liter times 2. Actually, you don't need to put the liter, also can just use 0.341 times 2.08 times 2. You get the cost of petrol going and coming back. Okay. Now, therefore, we save 3 ringgit 92 cents from the price of the packs of rice minus 1 ringgit 42 cents. That is the cost of petrol because you need to pay for this. Although you save this much, but then you have to pay for the petrol this much. So the difference that you can save is 2 ringgit 50 cents by purchasing 2 packs of 10 kg rice at store B. Okay, now we enter into the next part here. The next part will be after A, I am a very. So V stand for verifying and interpreting solutions. So let's see. V, okay, here. Verifying and interpreting solution in the context of the problem. So I just explain to you lah. It looks very complicated if you didn't really go and study it, but actually it's very simple. The resulting mathematical model. So over here in this section, verifying and interpreting solution in the context of the problem. You remember this part, you have to come up with a mathematical model. Okay, the mathematical model, you are going to get it from this step here. So S is equal to P1 minus P2 times N. Of course, I think you don't remember what is the variable over here represented. So I put it side by side so that you can see, you can compare. Here. So you can see the S over here. S is the difference of price in RM for purchasing 10 kilogram of rice at store B as compared to store A, meaning that's the difference of price. So P1, that's the price in store A, minus P2, the price in store B. And then you multiply by the number of pack of rice that you want to buy. So that is a 2. And then T stand for the difference in the cost of petrol in RM for driving to store B as compared to store A. So that is the difference of cost of petrol. That is equal to S over M. S is the distance between store A and store B. M is the petrol consumption rate of the car in kilometer per liter. Hopefully you still remember, this is the one, 76 kilometer per liter. After that, multiply by H. That's the current petrol price, and times 2 because going and coming back. Okay, now go back here. If S is greater than T, meaning that the difference of the price of buying the rice is greater than the cost of petrol, then it is sensible to drive to store B to purchase rice and save more money. Because you still can save how much just now? If you see, you still can save 2 ringgit 50 cents because the savings for the pack of rice after you deduct the cost of petrol, you still can save 2 ringgit 50 cents. Then, if S is less than or equal to T, meaning the price of the rice, the packet of rice, the difference of that 2 store is less than the cost of petrol, then we should not drive to store B to purchase the rice. This part you understand? I talk a lot, right? Huh?
Can you explain again?
Okay, I explain again. For example, the S, sorry. Okay, the S meaning that the difference of the price of the pack of rice. If the difference of the price of rice is RM10, and then the T is RM2, you can save RM2 of petrol. So it is sensible for you to drive to store B to purchase. This is store A, this is store B, this is your house. Okay, so it is sensible for you to go there. You can save 8 ringgit. But if your S is less than T, meaning, for example, your S is 2 ringgit right now, you only can save 2 ringgit if you go to store B, and then your cost of petrol is RM10. So actually, you have a, what you call this? It's just like you still, it's like you still have to pay 8 ringgit more to go to store B to buy the pack of rice. So it's not worth it. You understand now? Okay, yeah. So it cannot be less than, it must be greater than. So from the mathematical model later on, you are going to identify a few things. Okay, for example, over here, example of using the mathematical model. So they deduct the price in store A with the price in store B, they get 3 ringgit 92 cents. And then the T over here, after they find out the distance, divide by the rate, multiply by the petrol cost, and multiply by through and back. So they get 1 ringgit 42 cents. So since the difference of the price of the rice is greater than the cost of petrol, here, you can save more money by purchasing rice at store B. So hence, it is sensible to drive to store B. Thus, the mathematical model is able to solve the problem. Meaning, the mathematical model, this one, is able to solve the problem. So it can be used. Okay, now we continue. After V, I am a very robust robot. So the next one is R, right? R is refining. Okay, but before that, we still have further this one. From the constructed mathematical model, further exploration can be made. Okay, how do they explore this and make it nearer so that you can compare here? Okay, B, how far can store B be located so that it is an optimum choice? So how far can it be located? Can it be located 100 kilometers away from your house? Then you have to think, is it an optimum choice? If it is located 100 kilometers away from your house, you still can save more money. So over here, we are going to find out how far is the maximum distance that you can save your money. I'm sure if it exceeds 100 kilometers, it's not worth it to buy the rice from that shop anymore. Okay, so over here, we are going to do comparison to find out how far the store B can be located by using the formula, the mathematical model that we have here, the S and the T. Because you compare the S and the T, so you just have to use this part at the back, P1 minus P2 multiplied by N, and then you need to find out is greater than T. So the T over here is represented by the T up here. Can you say? They are comparing these two, P1 minus P2 times N, S over M times H times 2 on the right. So you need to find out, we substitute all the value that we have. This is the price of the pack of rice in store A. This is the price of the pack of rice in store B. This is the number of pack of rice bought. S is the distance. So this is the one that we need to find out, because we need to see how far is it worth to drive to store B. And the rest we are going to substitute with the value. M is the rate of the car, 17.6. H is the cost of petrol, 2.08. And then you multiply by 2 because go and come back. So after we found out, you just need to calculate using your calculator. You can get the value of S is equal to 16.6 kilometer. Less than 16.6 means if the shop B is located exactly 16.6 kilometer from your house, then it is not worth to buy. If it is located less than 16.6, for example, 16.5 kilometer, yes, you still can save a bit of money. If it is nearer, for sure, the more money, the nearer, the more money you save. That is the meaning over here. So this means that the distance between the two stores is less than 16.6 kilometer. Then it is sensible to drive to store B to purchase rice. So sorry, this is the distance between store A and store B just now, not from your house. Because from your house is already fixed. This is your house. The distance is already fixed. You go here, you go there. This is a fixed distance. So we don't count this in. We are calculating the distance between store A and store B to find whether it is worth it or not. Are you okay for the first one here?
Yes.
Yes, Okay,
Yep.
Now, besides you find the maximum distance that for when you buy the rice is worth it, you also can see how much the price of the rice that you can determine. For example, in store A, the price of the rice is 25 ringgit. Store B, the price of the rice is 23. What if the price of the rice in store B becomes 18 or becomes 24? So what is the maximum price Here, you can see number 2. What is the maximum price of a pack of 10 kilogram of rice at store B that will attract a person to drive to store B to purchase it? I'm sure some of your parents, when there is a promotion, a discount in some other supermarket, they will compare the price and then they will think, is it worth to buy? So is the cost of different, if the price of that good is a lot of different, compare after you deduct the cost, for sure they are going to further to buy the thing, right? So now we are going to determine the price, the maximum price of a pack of 10 kg rice that will attract a person. Okay, so the same thing apply. You use the same mathematical model like just now. P1 minus P2 times N, S over M times H times 2. So we want to find out the price in store B. We are just going to find the variable of P2 because that is the price of rice in store B. The rest you are going to substitute with all the value that we have earlier. All of this, you see, all the value is still the same. 6, 17.6, 2.0, add 2. And then P1, 25, 95. This one, are you okay? Are you okay?
Yes.
Yes, so after you found out everything, you can get the price of the pack of rice in store B is less than 25 ringgit 24 cent. Okay, what does it mean over here? The price in store B must be less than 25 ringgit 24 cent, only then it is worth to go and buy. If the price is 25 ringgit 24 cent, then it is not worth. Okay, that is the meaning over here. You can use the mathematical model to find out the distance that is the optimum choice and the maximum price of a rice. Okay, that is the mathematical model. So after this, V is R. R is refining the mathematical model. Now we need to refine the mathematical model. How do we refine? There are a few questions before you refine it. You can ask yourself. So these are the example of the question. Can we have a negative answer? You will ask yourself. Are our assumptions relevant and defensible? Does this model follow the assumptions made? Do we need to add more assumption? What if our assumptions are wrong? How does that impact our answer? What if the scenario changes a little? Do our results change a lot or a little? To what extent do these changes affect the decisions made? And here, is this model still valid when we increase or decrease the input variables? For example, if we keep all else constant, but decrease the value S, the distance between the store, do we see a decrease in T, the cost of petrol to travel the extra kilometer? So you are going to reflect all the question over here and find out whether you can refine the mathematical model or not. Okay, so we enter into the fifth one, refining the mathematical model. Okay, the assumption made regarding the route between the house, store A, and store B is a straight line. Earlier, we assumed that it is a straight line, right? So it needs to be revised because this one for sure is not true unless you live very near to the store A, store B, very near. Okay, if the route between the three places is not a straight line, how does this impact our model? So you can see the house, this is store A, 2 kilometer distance, but then have to turn down here with the distance of 4 kilometer to reach store B. So if new assumptions are being made, then the model needs to be revised to reflect this change. Okay, so this is the example on how to refine the mathematical model. Lastly, you report the findings. So use symbols and diagrams when necessary to report the findings. For example, the value of a person's time is not considered in this model. Is it worth driving an extra 12 kilometers for someone to save 2 ringgit 50 cents? According to this model, saving 5 cents is considered worthwhile. So for someone like a manager, the one who is a very busy person, is it worth for him to drive an extra 12 kilometer? 12 kilometer is quite far, right? If you include the traffic jam and so on, you need a lot of time just to save 2 ringgit 50 cent. Whereas he himself within that time, he can make more money. Okay, so this is one of the finding that you have to find out. Now, the second one, the model did not account for any environmental consideration. Is it environmentally responsible to drive an extra 12 kilometers just to save 2 ringgit 50 cent? What does it mean over here? Means it did not account for environmental effort, such as effort to reduce the carbon emission. So it's like not environmental friendly anymore because they are emitting the carbon. Okay, so you understand over here?
Yes.
It's a very long topic with all of the explanation. Now we look at the example. You remember the 6 component? I am a very robust robot. So we look at an example 1 given. I found out most in the workbook, they only ask you to identify and make assumption. They didn't ask you to do the verifying and so on, whereby you have to come up with a mathematical model. But in the next lesson, we still have to try to answer 1 or 2 of that types of questions so that you know what to do if these kind of questions really come out. Okay, now we look at the memory box first before we enter into this. This one is about simple interest. You learn this in Form 3. It's a reward given to the depositor at a certain rate on the principal amount for a certain period of time. Simple interest can be calculated using the formula I equal to PRT, where I is the interest, P is the principal, R is the interest rate, and T is the time in years. So this one is just like a fixed deposit to represent the simple interest. Okay, now look at example 1. Jeremy saved 4,000 at Bank Bunga Raya with a simple interest rate of 1.5% per annum. Jeremy wants to buy a computer worth of 4,455 with his savings. How long does Jeremy need to save? Identify and define the problem. Okay, so in this problem, we know the principal and the interest rate. The interest from the saving is the amount that Jeremy needs besides 4,000 to buy the computer. So we need to determine how long Jeremy needs to keep his saving in the bank. Okay, if he want to buy a computer worth 4,455, that is the identifying and defining the problem, this part. Okay, B, I need to be fast because the time is running here. B, determine the assumptions that need to be made and identify the variable in solving the problem. So, assumption, we need to assume that the interest rate does not change during the period of our interest calculation. So, otherwise, the formula I equal to PRT will not be appropriate because this will not be simple interest anymore. You have to use the compound interest already. Okay, second, we also need to assume that the price of the computer does not change when Jeremy has raised the required amount of money. Okay, he might raise the amount of money after 5 years. So you need to make assumption the price of the computer is still the same. Okay, these are the assumptions. Variable involve I for interest, P for principal, R for interest rate, and T for times in years. So this one you have to come up with your own variable. If it is the formula that is well known, that is the one that you have learned before, then you just use it. If it is something new, you haven't learned that kind of formula before, you have to come up with a mathematical model, then you have to use your own variable. Okay, so that is example 1. Then this one. Oh, this one is another sample, another example. Okay, I'm not going to talk about this example right now. It's a lot of time over here. The journey of a boat. This one is on 8.1a. Okay, never mind. This one I'm going to ask you to do it as an exercise. So for today, I'm not going to ask you to do the exercise in your exercise book anymore. Today only, because I've already get ready a live worksheet exercise for you. You can check in your GC later on. This is the live worksheet. So very simple. You can finish within, I think, 10 minutes. Okay. So this is the live worksheet. I think consists of about 3 pages. I make it simple for you. You don't have to write so much thing. So for here, you just need to type down what is the meaning or the definition of a mathematical model. Fill up everything. Make sure you don't simply spacing and then you write. Make sure you start from the beginning, or else your answer will be wrong. Okay. Next, this one, you just need to choose the correct one to fill in the blank like this. And then question number 3, you are given a situation. You need to find out over here. So I want you to do the matching. It's like the primary school work. You just need to find out from the first component, identifying and defining the problem, which condition over here is identifying and defining the problem, and so on. Which one is come up with a mathematical model? Which one is make assumption and identify the variable, this part. So you got to find out. Okay. And the last question here, they give you a question over here. You identify and define the problem. So if this is the first one, you put it in the first one. You don't put to the last, and then maybe you find out something here. You arrange it according to the sequence given from here, top to the bottom. Same with the second part here, so that you can get the correct answer later on. After you have done it, click finish. And then you can see your answer. If it is in green, meaning that you got it right. If it is in red, meaning that it is wrong. So this one is red, wrong. And then this one is red, it's wrong. So 0 mark. I want you to print screen all of these pages and attach it in your GC later on. Can or not, class? Attach it later on.
Madam, after kena semak ke madam?
Tak perlu semak, dia akan semak sendiri. Because when you press the finish button, just you check your answer, they will check for you.
Not that madam. I mean yang perlu di screenshot ke madam tu selepas kena semak ataupun sebelum?
Ulang lagi soalan kamu, Senai.
Kan kita perlu screenshot hantar dekat madam nanti. Jadi yang tu screenshot yang dah kita tekan finish ataupun sebelum tu madam? Selepas
tekan finish, selepas kamu dapat markah.
Oh, okay. Thank you, madam.
Okay. You have any other question, class?
No.
No question, so make sure you finish it.